So in this video we're going to learn how to practice replacement and non-replacement problems and generate your own, as it were, worksheet. So we're going to start by drawing a jar or an urn, and we're going to then fill that urn with marbles of two or more different colours. Okay, let's have a look at the rules that we use to generate these problems. So first of all, we're going to fill our urn rolling one dice for each colour. Secondly, we're going to work out the sample space. Thirdly, we're going to fill in the Venn diagram, and then we're going to complete a tree diagram just to check really that we've done everything correctly. So let's start filling in our urn then. We've got 3, 4, 5 yellows, and let's add a couple of reds then. So 2 reds, 5 yellows. For our second urn, again we'll randomly fill our urn, this time with yellows and blues. And we've just increased our numbers a little more for this second problem. So 3 blues then and 6 yellows. Okay, now we're going to draw our Venn diagram skeletons. So first of all we draw our universal set, so the rectangle around the rings, and then 2 overlapping rings in each of these. Now the first of these Venn diagrams we'll use for non-replacement, so it's when we're not replacing the marble that we draw out in the first draw. Okay, so let's give that a go. Very first thing then we're going to do is non-replacement. So this Venn diagram will be for we'll call it non-R, non-replacement. So first operation, can we draw a simple sample space diagram? Okay, well done if you gave that a go. If not, just follow through with this explanation and have a go the next time round. So first of all, we count up the number of possibilities we've got here. We've got 5 yellows, 2 reds, so that's 7. So in the first event, when we first draw, if I draw it here, we're going to have one of 7 possibilities. So I can draw that something like this. And then in the second round, when I'm not replacing, I'll only have 6 possibilities. So for each of these branches, I just want to draw something like that. 1, 2, 3, 4, 5, 6. Okay. Let's draw that around there. And you don't have to do this. Some people can easily, or fairly easily, think about this just in their heads. But a diagram, always if you can draw a diagram, it helps you think about things, it helps you visualize what's going on, and it generally avoids mistakes. So with a Venn diagram, we normally work out the middle overlapping section first, the intersection here. The first event, A, is going to be when we draw our first marble and check is it a red or not, and our second favourable outcome is event B. So when we draw again, we're again asking have we got a red. So if we go to our sample space diagram and think about what kind of number are we going to fill in here, how many opportunities will there be? Well, first of all, we have to have a red in event A, and then we would have to have a red in event B. Now, there wouldn't be any second possibility of getting a red because we've already drawn a red. So there's only one possibility along this arm here. Along this arm here, we've drawn a red and another red, and so we've got 2 chances of drawing red, 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 red. So that gives us the answer 2, so the number that we write in here is 2. Okay, now let's consider what would happen, how we would only draw a red in event A. So this section here, only in event A, only in draw A. So that would be when we've gone along here and we've drawn a red, but we haven't drawn it in the second event. So it would be 1, 2, 3, 4, 5. So I'm going to use the tally mark system here. So 1, 2, 3, 4, 5 here, and 1, 2, 3, 4, 5 here. So all of these would have to be drawing only in event A. So that's 5, add 5, in other words 10. Finally, what number are we going to fill in here? That section representing only drawing a red in event B, in the second draw. Well, that would have to be these here, 1, 2, 3, 4, 5. And now we've got 2 opportunities to draw a red because we haven't drawn a red in the first draw. So we've got 1, 2 here, 1, 2 here. Let's draw it here. 1, 2 here, here, and finally here. So that's 2, 4, 6, 8, 10. So 10 altogether. And that gives us a probability of drawing red in event A as 10 plus 2 out of what? Well, our total that we've got here is the number of branches around the outside. So if we just count up around the outside, we've got here 6 times 7, so that would be 42. We can write that here. So our total number of possible outcomes is going to be 42. And that means that if I add these together, 10 add 2 is 12, plus 10 is 22. Take that from 42, we should have 20 branches where we can't see, where red hasn't been drawn either in the first draw or the second draw. So we never draw a red, we only draw yellows. And we should be able to see this here. So we've got 1, 2, 3, 4 here. So 1, 2, 3, 4. Another 4 here. Another 4 here. And here. And finally here. So we've got 1, 2, 3, 4, 5 times 4. 5 times 4 is 20. So we've completed our Venn diagram. Okay, that's with non-replacement, yes, not replacing. So now we're going to consider replacement. So when we replace our marble. So let's go back to drawing our sample space. So we've got 1, 2, 3, 4, 5, that's 6. I haven't quite fitted that in very well, so let's just erase that. Okay, so we've got 7 arms. And this might be a good point, if you haven't already, to pause the video and see if you can complete the sample space diagram. Okay, so in the second round, because we have replaced our marble, then we're going to also have 7 possibilities because we've still got 7 marbles in the jar. So if I fill in these arms here, I'm going to have, how many have I got there? 6 and 1 more, 7 now on each of these arms. So, like this. And here. tricky to squeeze in now. Okay. And lastly, okay, there we are. So now let's consider the Venn diagram, and again, good chance for you to pause the video and see if you can fill in that Venn diagram. So we generally start with the intersect, and this is when we are only picking, well, not only, when we're picking a red in both the first drawer and the second drawer, event A and event B. Well, just as before, there are two opportunities in the first drawer, but because I've replaced it, there'll also be two opportunities in the second drawer as well, because we still have two red marbles to choose from. So we've got a red, a red, a red, red. These arms representing a double pick, so red picked both times. Therefore we've got 1, 2, 3, 4, so 4 in the intersection here. Okay? Now, what about only drawing a red in the first drawer? Well, that would be these arms here. So we've got 1, 2, 3, 4, 5 again, and 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. 5 add 5 is 10. So only picking red in the first drawer would be 10. Okay, what about in the second drawer? Only picking a blue, a red rather, it's event B, only picking a red in the second drawer. What would that be? Okay, so if we think about this, I've already cancelled out these, so I can't go down these branches here, so it has to be down these branches here. I've got, let's think, we've got a red and a red, a red and a red, a red and a red, a red and a red. So again, we've got 2, 4, 6, 8, 10 opportunities of only picking red in the second drawer. Okay, what about the total number of possibilities? Total number of possible outcomes? Well, that's going to be 7 times 7. So I've got 7 in each of these branches here, and I've got 7 of those. So it's going to be 7 times 7, 49. So 49 total possible outcomes. So 10 add 4 is 14, add another 10 is 24. 24 from 49 is 25. So I should be able to look at my diagram and see 25 outcomes where we didn't choose a red at all, we only chose yellows. So that's going to be here. So 5 here, 1, 2, 3, 4, 5. 5 here, 3, 4, 5. 5 here, here, and here. So 1, 2, 3, 4, 5. 5 times 5, 25. So that's completed our first jar and our first two Venn diagrams. So now that we've got to this stage, you might want to pause the video at this point and work on the second jar. The second jar has 3 blues and 6 yellows. So again, think about the sample space. Think about it first with non-replacement, then work on replacement, and see if you can fill in the Venn diagrams. So we've now got a diagram that should look something like this. We've got 3 blue marbles, 3 favourable outcomes. So we've got 3 opportunities in the first round to pick one of our blue marbles. And if we've picked a blue marble but we haven't replaced it, then there's only going to be 2 of these branches here. So where we've got a favourable outcome, blue, blue then. So 2 here, blue, blue, and 2 here, blue, blue. So 2 add 2 add 2 makes 6, so we've got 6 now in our overlap region. Okay, so what about only drawing one of our favourable blue outcomes in the first round, but not in the second? Well, that would be here, 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 in here, and in this area here. So we've got 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. And here we've got a further 6. So 1, 2, 3, 4, 5, 6. In other words, we've got 12 where we only draw a blue marble in the first event, but we've also got this. I nearly forgot. I'm sorry. So we've got 12 there, and we've got 1, 2, 3, 4, 5, 6. So we've got another 6 there. So in fact, we've got 18 altogether. So 18, and the sample space diagram makes that then very clear. Okay, what about this area here when we only pick one of our favourable outcomes, the blue, in the second draw? Well, it can't be any of these branches here, so it has to be this, 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 and this. So we've got 1, 2, 3, 4, 5, 6 here. So it's going to be 6 times. So if I haven't drawn a blue already, there must be 3 in each of these. So 1, 2, 3. Blue, blue, blue. 1, 2, 3. Blue, blue, blue. 1, 2, 3. Blue, blue, blue. And here. And finally here. Blue, blue, blue. So that's 3 times 6. And so we've got 1, 2, just check, that's 6. 3 times 6, again, we've got 18 favourable outcomes, only drawing blue in the second round. And how many possible outcomes have we got altogether? Well, we've got 8 in each of these branches. We've got 9 branches, so it's 9 times 8, which is 72. So if I add these together now, I've got 18 add 18, that's 36. Add another 6, the 6 in the middle gives me 42. I should have 30 then, 30 branches where we don't pick a favourable outcome, we don't pick our blue either in the first round or in the second round. So we only pick a yellow. There should be 30 outcomes. And let's have a look at our diagram and see if that makes sense. Well, it's got to be these branches here, 1, 2, 3, 4, 5, 6, and here we've got 1, what are these? So this is 8, take away those 3, that's got to be 5 in each of these. 1, 2, 3, 4, 5. So we've got 5 here, 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 and that's it. So 1, 2, 3, 4, 5, 6. So we've got 6 5s. 6 5s are 30, so that confirms that we've correctly filled in our Venn diagram. Okay, finally, pause the video at this stage if you're confident now and see if you can draw out a sample space diagram for replacement. So you should have something like this. And now if we start to think about then our event A and our event B, start with the intersection here. So if we think about, again, 3 opportunities in the first round to pick a favourable outcome, and then in the second round, what have we got? Well, we've still got 3 because this time we've replaced. Okay, so we've replaced the blue marble that we pulled out, so we've still got 3 left. So again here we would have blue, 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 and here blue, blue, blue. So 3 plus 3 plus 3 gives us 9. So we put 9 in the intersect here. So that's the probability of picking a blue in both the first draw and in the second. So now, what about only picking a blue in the first round in event A? Well, that's got to be along these diagrams here. We know we've got 9 along these branches. Sorry, we know we've got 9 here. So 9 minus 3, so that's 6. You should be able to just about count 6 there. So we've got 6 here. I'll just draw a 6 there. We've got 6 here, and we got 6 here. So that gives us 18. And you can see the pattern here. So we're expecting that this would be 18 as well. Let's just check that it is. So this is the event that we only draw a blue marble, get a favourable outcome in the second draw. So let's have a look at our sample space diagram. Well, if we only draw it in the second draw, then it must be these branches here. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6 rather, 6. So 6 where we don't draw it, but then we've got 3 opportunities here. So 1, 2, 3, 1, 2, 3, 3 here, 3 here, here, and that's it. So 1, 2, 3, 4, 5, 6, 6 times 3, 18 again. So how many possible outcomes are there altogether? Well, it must be 9 times 9. So 9 times 9, 81. And if we add these together, we've got 18 add 18 is 36, add another 9 is 45. 45 then from 81, so 81 minus 45 is 36. So we should have 36 branches where we only pick a yellow. Let's have a look. 1, 2, 3, 4, 5, 6. So 6 times 6, 6 times 6, 36. So well done if you got that right and you filled this in correctly, and if not, just keep practicing. Make your own urns, try with different numbers of balls, but hopefully you'll get more and more confident about what a sample space diagram is and how to fill in Venn diagrams to show the sample space. Okay, finally what we're going to do is draw some tree diagrams and just show you how to fill in these fractions or percentages onto a tree diagram. So let's do that straight away. And here, here, and here. So standard tree diagram for 2 events, where the first event is represented by this branch here, and the second event is represented by 2 branches now because we've got these 2 possibilities in the first event. So if you are confident in filling in tree diagrams, good opportunity to pause the video and give it a go. Okay, so what we're going to do is look at our Venn diagram, also look at our urn here, and see if we can figure out how to fill in a probability tree diagram as quickly and accurately as possible. So the first thing is we've got probability of A. So the probability of A is 12 out of 42, according to our Venn diagram. Or if we just think about it, we've got 2 out of 7. 2 out of 7. So 12 divided by 6 would give us that 2, and 42 divided by 6 would also give us that 7. So the second branch here should equal the complement of 2/7, so that would be 5/7. Looking at our Venn diagram, that would be if we don't pick a red, if we don't have a favourable outcome in the first round, so that's got to be this 10 and this 20. It would be then 30 out of 42, so 10 out of 20 out of 42, and 30 divided by 6 gives us 5, 42 divided by 6 gives us 7. Okay, see if you can fill in the other branches, pause the video at this stage and give it a go. So, probability B given A is going to be, so probability of B is 12, but given A. So the thing to look for is the given A. So we've got B given A. B given A is going to be 2 out of 10. So it's 2 out of, not 10, sorry, 10 add to 12. Well, 2 out of 12 equals 1 out of 6. So if I put my red here and my red here, then to get a red, and then a red is going to be 2/7 times 1/6. Okay, what about the chances of not getting a red? So not getting a red if you drew a red in the first round. So referring to my Venn diagram, not getting a red would be 10, out of, I've got myself a little bit muddled, which does tend to happen with these things. So I think what I'll do is keep that in the video so you can see that everybody gets muddled. Okay, so not getting a red, this branch here is not B, but still given A. Okay, so we've still got given A, so that's 10 plus 2, that's 12, but not getting B, well, that's going to be 10 out of 12. Okay, so I've unmuddled myself. 10 out of 12, which is then going to be 5 out of 6. And that, again, that makes sense if you think it through using using logic, using reasoning, then you should be able to see that that makes sense. So we've got 2/7, 5/7, 1/6, 5/6. Now what about this branch here? Pause the video if you want to give that a go, and then check the work solution. So this is not getting a red, and this branch here is red, and this is not getting a red. So if we're thinking about red, a favourable outcome, so in other words, probability of B given not A, well, not A is going to be 10 and 20, and B is going to be 10. So it's going to be 10 out of 30, 10 out of 30, and 10 out of 30 is 1/3, obviously, but it's also 2/6. And again, that should make sense to you if you're just working using logical reasoning. 2 out of 6. Finally, not getting a red after not getting a red. So not getting a red was 10 add 20, which is 30, and not getting a red again in event B is going to be 20 out of 30. So 20 out of 30. And again, that's 2/3, but that's the same as 4 out of 6, which you should get just from logical reasoning. So now this example with replacement. So first of all, again, we've got red and not red. So first of all, the red, well, that's 10 plus 4, which is 14 out of 49, which simplifies to both divide by 7, so 2 out of 7. And getting a red in the second round, so event B, again, would be 14 out of 49, so that would be 2/7. So same number again. Okay, which makes sense because it's exactly the same scenario in the second round. So this branch here now is going to be if I don't pick a red, so that's going to be if you don't pick a red, so no red here, so you've got 10 plus 25, so that's going to be 35 out of 49. Which divides by 7, so 35 by 7 is 5, and 49 becomes 7, so 5/7. And those add up, 2/7 and 5/7, so that makes sense. Again, if I think about not getting a red, it's going to be 10 add 25, so that's 35 out of 49, which is 5/7. Here, if I get a red in the second round, but I didn't get a red in the first round, so it's not getting a red is going to be that 10 out of 25, but getting a red is going to be that 10, so it's 10 out of 35, which simplifies, if I divide by 5, simplifies to 2. Divide by 35 divided by 5 is 7, so 2/7. And lastly, if I think about not getting a red both times, then in this example, that's going to be, again, not getting a red is 10 add 25, so this time that's 35, so this time it's the 25 out of the 35, 25 out of 35, which again divides by 5, so I've got 5 now, and 35 divided by 5 is 7. So that completes that one. Okay, let's move on to the second jar and the non-replacement example. Pause the video if you want to give it a go. So the work solution would go like this. So again, we've got to think about the probability of getting this time a blue, so that would be 18 add 6, 24. So 24 out of 72. And if I think about what I want to get to, I want to get to 3/9. So if I divide both of these by 8, then 24 divided by 8 would be 3, and 24 divided by 72 would be 8. So that gives me my 3 out of 8 that I can literally see in my jar example. Not getting B then would be 18 plus 30, so that's 48 out of 72, which simplifies to 5/8. And in my second event, if I fill that in, what would that be? Okay, so I've got to think about getting a blue in the second event, given that I did get one in the first event. So given this ring here, this set here, then I've got to get blue again. So it's going to be 6 out of 18 add 6. So it's going to be 6 out of 24, which is 3 out of 12, or I could say 2 out of 8. So divide numerator and denominator by 3, and I get 2 out of 8. Well, that makes sense again. If I think about, I haven't replaced, so I've now only got 2 marbles, so that seems to work out nicely. If I think about my branch here, when I'm not getting a blue, but I did get it in the first round, again, given that it's going to be out of 24. Whoops, let's just erase that. There we go. Out of 24. So this time I've got to say I did not get a blue. So if I don't get a blue, it's going to be 18 out of 24, which if I divide by 3 again, I will get 6 out of 8, which again you can derive from by logical reasoning. All right, going to this branch here, I've got then a blue, but I didn't get a blue in the first round. So blue, but given that I didn't get a blue, would be 18 out of 18 plus 30, 48. So again, if I want to think about this in terms of, well, this time it's going to reduce down to, if I divide by 6, I will get 3. 3 out of 8, so 3/8, which again seems to make sense. So I've got 3/8 this time. And finally, not getting a blue is going to be 30 out of 18 plus 30, 48, which gives me my complement of 5/8. Okay. So lastly, with replacement, I should get the same sort of pattern as I had here. So let's see if I do. So first of all, I've got now out of 81. And I've got 18, add 9, 27. And if I divide both those by 9, I will get 3, and 81 divided by 9, 9th, which is exactly what we've got visually in our example to start with. Okay, so now I've got to think about what if I, don't get a blue? Well, that's going to be 18 plus 36, so that's going to be 54. 54 out of 81, divide by 9, gives me 6/9, which is the complement of our 3/9 here. So, see if we can fill in the final branches here, and check that these fractions should be the same as these fractions here. But let's have a look and work it out through reasoning first of all. So if I look at my diagram and if I think about getting blue in the second round, given that I did get blue in the first round, so it was a favourable outcome, then it's going to be 9 out of 27. So 9 out of 27. Okay, well if I divide by 9, I've got 1 out of 3. But I don't really want to think about it as 1 out of 3, so I'm going to multiply that by 3, and that gives me, so if I divide by 3, in other words, yeah, so divided that down too much, let's have another go. So if I divide by 3, I get 3 out of 9, and then that feels much better. Exactly as I had here, 2/7 followed by 2/7, I've got 3/9 followed by 3/9 followed by 3/9. So good. So next one, I've now got not getting a blue, given that I did get a blue. So here, but not getting blue, so I get 18 out of 27. Again, if I divide by 3, that will give me 6 out of 9, which is what you'd expect. Let's have a look at this branch then. Getting a blue, okay, given that I did not get a blue, so it's this 18 and 36. So this time it's going to be out of 18 and 36 is 54. So given that I did get a blue, is going to be this number here, 18. So it's 18 out of 54. And if I divide by 6, I get 3/9, which is exactly what I got here. So that's good. And again, for my final branch, not getting a blue when I didn't get a blue before means I've got to write down 36 out of 54, which is 6/9. So again, the same as I had here. So hopefully going through that practice video has been instructive to you. It's given you the chance to practice these skills of working with Venn diagrams and working with tree diagrams, but also it's given you a chance to see the difference between replacement and non-replacement, so that you become more confident about what that means and what it implies when we're thinking about probability.